This lesson we're looking at investigating associations between two numerical variables. So when we have two numerical variables, the best way to represent the association visually is to use scatter plots. Scatter plots have two axes, and on the horizontal one will always have the EV, the explanatory variable, and on the vertical one will have the response variable. And then we put all our data as a single dot. So this scatter plot, for example, has a lot of data. As you can see, there are many dots. And it gives us the visual representation of the association between the two by forming sort of a pattern on the graph. And the ones that don't go with the rest of the graph, such as this one here, could be a potential outlier. So when you're drawing scatter plots, we'll practice one here using this data here. First thing you need to do is determine which one's going to be your EV and which one's going to be your RV. And this is about people's height and weight. So you do need to use a bit of common sense here, thinking that, well, if someone's taller, generally they'll weigh more. Not necessarily if they weigh more, they're taller. So your height is going to be, your EV is going to be the height, and RV is going to be the weight. And according to that, you put those two variables in the right place, EV on the x-axis. And then after that, you obviously want your scales to be consistent. So going up by the same amount every time. And if you're not starting at 0, you need to indicate that by putting a break there. And then the rest are just putting the data in as dot points. And then as you can see, this one, there's a bit of a correlation there. There's a relationship you can see between height and weight. Obviously, this can be done on the CAS as well. It can be done relatively easy. You just need 2 columns, and you need to obviously label them as well. I'll put the data in and go to a new page, data and statistics, where you put the variables in the right place, and it gives you a scatter plot right away. So try that out if you haven't done that before. And in some cases, it will save you a lot of time. You don't have to think about your scaling or what it's going to look like, especially if you want us to draw one just for visual purposes. You can draw one on the CAS quickly and sort of see what sort of correlation they have. So when we have a scatter plot, we can find out a lot about the two variables. And the ones that we want to really focus on are these 3: direction, form, strength. And then also we can quite easily find the outliers as well. So starting with direction. Direction is to do with either having a positive or negative correlation, or you could have no correlation, then there's no direction. So for example, if you have a positive correlation, and by the way, when we look at scatter plots and talk about directions and whatnot, we're always looking at it from left to right. That's always the direction that we go. So looking at this graph from left to right, you can see it's going up generally. All the dots are sort of heading upwards, whereas this one here, they're going down. So if it's going up, we call it a positive direction. If it goes down, negative. And something like this one where you can't really see what the direction is, you can say there's no correlation. So in terms of direction, if it's positive, generally speaking, if the RV increases, then the EV increases. If it's obviously negative, then if the RV decreases, then the EV increases. So meaning, looking at this one here, we have the EV here. EV is always here, RV is here. As you can see it either way. As EV increases, the RV goes down. So you can see as we go sort of up the scale of the EV, you can see the values of RVs going down. Obviously, you can see it the other way. You can say that as RV increases, you can see the EV is decreasing, like going down that way. And again, if there's no pattern, you can say there's no pattern. Next thing to look at is the form. Form is to talk about whether it's following a linear trend or non-linear trend. So this one is a little bit tricky, so you need to be quite careful because some of them are a bit hard to distinguish. But like this example here, it's very clearly follows a straight line, so that's linear. Same as this one, except for this one, which is possibly an outlier. You can see all the rest. If you were to draw like an outline of where all the dots are, it's very obvious that it's a straight linear line. This last one here, if you were to draw an outline of sort of where everything is, you can see it sort of curves in. So for those ones, they are non-linear. And this last one, and possibly the most important one, is the strength of your association. And this only applies to linear association. So if it's non-linear, we cannot use what we're about to learn, which is the correlation coefficient, or the R value as you know it. So again, that's only for linear. So the R value, which you calculate using the CAS, or sometimes it's given to you, it explains how strong, well, it explains the strength of your linear association. So example, if you have a correlation of 0, it means there's no correlation. If it has 1 exactly, and it only go up to 1, that means it's perfectly positive, like a positive straight line with no dots sort of out here. And if it's -1 and it does not go down lower than -1, it's a straight negative line. So the scaling only goes from -1 all the way to +1. So there's numbers between those two. So for example, as you get closer to -1, you have a stronger association for negative association. As you get closer to +1, you have a stronger positive association. So example here, we have +0.9, which is really close to 1. So then you'll expect to see almost a straight line. Whereas you go close to, actually this one's still positive, 0.5, so but it's not as strong as 0.9 or 1. So you'll see a straight line, but it's a bit wider, it's a bit more spread out. Same applies for the negatives. If it's -0.7, fairly strong straight line. -0.3, very weak straight line, so very wide. And anything lower than that, you'll see it's almost random. You can't really tell there's association there. So here's a little scale. So when you find your R value, you can refer to this scale to help you describe what the association is. So anything between -1 to -0.75, you can say it's strong, and it's obviously negative. Same can be said for the positive, 0.7 to 1, strong positive, so on and so on. They're pretty straightforward. And if anything lands between here, so being less than 0.25 to 0 or 0 to -0.25, you can say there's no correlation. So if you're given the R value, let's say it's negative 0.62, then you are somewhere here, as you can see. So you can describe the relationship as moderate and negative. So this example here, we're bringing all the four things together that we learned in this lesson: direction, outlier, form, and strength. So let's do them together: direction, outlier, form, and strength. So direction, hopefully it's obvious to you. We're looking at left to right. This is positive, this is positive, this is positive. Outliers, not as obvious, but I think in these three cases it is obvious there's no clear outliers. So just let's write X for not having any. And for the form, they all seem linear. You can see they're all straight lines. So linear, linear, linear. And strength is, well, we are estimating here, but we can give it a value of R and we can also describe it as well. So let's do that. So we do both. So if we were to estimate the R value, this one, I would imagine would be around 0.5, 0.6, or maybe let's say 0.55. It is positive. And if we were to describe that as well, it will be somewhere here. So we'll call them moderate and positive. Next one, you can see a lot more together, forming a more straight line. So it's probably like a 0.8 and still positive. So if we were to describe that, it'll be like somewhere here. So strong and positive. This one right here, it's almost perfect, but it's not quite perfect. You can see some of them like a little bit off this straight line by very, very little. So this will be almost like 0.95 or even higher. So this will be very strong and positive as well. All right, these ones here, you can see they are all negative. And then what was the next one? Outliers. No clear outliers here either. So this is direction, outliers, form, and strength. Form, they're all linear. You can see they're all sort of forming a straight line. You can see they're all linear. Strength wise, they're all negative. As you can see, going left to right, they are going down. So this will be roughly negative 0.5-ish. This will be roughly negative 0.8-ish. This will be roughly negative 0.95-ish. And if you had to describe them as well, you refer to the scale, find where it is in terms of the R value, and do that. And this last one seems random, so no direction. There's no outliers. It doesn't seem like they're all random. And there's no form, so it's not a linear thing, not a linear scatter plot. And in terms of the R value, it's going to be very, very weak. So maybe like 0.1, or could be like negative 0.1, I mean, or it could be like 0. This next one here, you have two variables, again, numerical variables, hours of study and test results. So again, you need to decide, well, which one's going to be the EV and RV. You would imagine more you study, better you will do. So hours of study is going to be your explanatory variable. This is going to be a response variable. So obviously you put those in the right places. Have your scales. When you do your scaling, always look for the lowest number. So for this one, it's 0.5. And look for the highest number, which is 4.5. So you would imagine that, well, you can sort of start at 0. So you want to go a little bit lower than your lowest. So you start at 0, as we did here. And then you want to go a little bit higher than your highest, so you can go up to 5 like we did here. So that should be how you decide your scaling. After you decide it needs to go from 0 to 5, you obviously divide the rest evenly and put it on your scale. For the test results as well, 92 is your highest, so you probably go up to like 100. And look for your lowest, and I think it's 45. So you want to start at around 40. And because you're starting at 40, we're not starting at 0, so you need to show that there's a little break there as well. Alright, this very last question that we'll do together, it says comment based on this scatter plot and the data. Comment on whether a relationship exists between the two variables that we just graphed, and describe it. So this is where you mention all these things: direction, outlier, form, and strength. So in terms of the strength, you can see very strong, it's positive. So you want to say there's a strong positive, and it is linear, it forms like a straight line. And as you can see, there's no clear outlier, so you mentioned that as well. So that's all you need to do.